Today, I remain Elijah Idehen, and this class is brought to you by WAEC Humanitarian Foundation. So, we're going to take bearing and distances. Bearing and distances. And this is a topic under mathematics, and has to do with what? Trigonometry, one of our trigonometry called what? Triangle, most of the times. So, bearing and distances. When we say bearing, what do we actually mean? Bearing. Bearing is just the direction or the location of the point on the Earth's surface. Bearing is the direction or location of a point on the Earth's surface. What is the direction? What is the direction? How do we move from one point to another? How do we determine the location of a point from another point? So that is what we are going to look at here. So we are saying that, let's assume this is point A, and we have another point B over here. So how do we go from point A to point B? Or how do we move from point B to point A? That's what bearing and distance is all about. So whenever you're moving, you must first guess your direction before you apply your distance. So you must first get your bearing before you apply your distance. You can't say you want to get somewhere and you are not focused on the direction, or you're not facing the direction where you're going and you say you want to get there. No. You have to get the direction facing the direction opposite to you, then you apply your distance. So from here, if this person, okay, if this one wants to get here, what does the person have to do? This A now will have to move towards this direction and apply a distance. It won't just start from here and go straight or go anywhere he wants. No, wherever it's facing. No, you have to face the direction. Face the direction you're going before you apply the distance. So you must first determine the bearing of a particular place before you can apply the distance. That's how we can make it easy. So bearing is of two types. We have the 3 digits bearing and then the compass bearing. 3 digits bearing is just saying that we have 3 figures. So whenever you are measuring your bearing, you just have to apply 3 figures. So the bearing, 3 digits bearing can be of the form 0, 30 degrees. Can be of the form 0, 60 degrees. Why are we calling 3 digits bearing? Because there are 3 figures, 3 numbers. That's why it is called 3 digits bearing. So if you are giving 30, just know it is the same thing as 0, 30. If you are giving 50, no, it's the same thing as 0, 50 degrees. So that's 3 digits bearing. But the same way you can be giving 120 degree, 150 degree. This one is complete digits, 3. That's a 3 digits bearing. So when we are talking about the compass bearing will give you the direction where you're starting from and the direction you're going. Now, like we all know, there are 4 coordinates or quadrants. 4 quadrants, and this is north, east, west, and south. On all these quadrants, we have angle 90 degree each. Angle 90 degree each. If we have angle 90 degrees, we can divide between this north and east. We have another quadrant there, which is northeast. And this will be 45. This will be 45. Yet we still have another again. This one will now be southeast. Yet we still have another. Then this one will be southwest. and then the last, this one then be what? Northwest. But the four basic quadrants is what? The north, east, south, and what? West. So all these will give us 45 degrees. 45 degrees. 45 degrees. So, a bearing is talking about the direction, while distance is what? The movement in between two points. The bearing will give you the direction towards that point, and apply the distance will make you get to that point. So let's look into this in details. Let's look into this in details. For example, the bearing of point A from B. Bearing of point A from B is 060 degrees. Find the bearing of point B from A. Find the bearing of point B from A. How do we get this? Say the bearing of point A from B is 060. Find the bearing of point B from A. Whenever you are doing any bearing question, you must first start with your coordinate points. Your coordinate points will represent a particular point. You must draw your coordinates. So your coordinate will represent a particular point. So your starting point now is what? From point A. So we are saying this is point A. This is where we are starting from. So to get to point B, we need two things. To move from one point to another, you need two things: your bearing and the distance. If your bearing is not correct, then you can't get to your location, never. So your bearing and your distance must be what? Correct. So here, they are saying we move from point A to point B. Bearing of point A from B. So this is different. The bearing of point A from B. Meaning that we are starting from B. That's our starting point. So this will be our point. Our starting point is what? B, not A. So you have to read the question and make sure you understand. You know what the starting point is. Our starting point is what? B. The bearing of point A. We are trying to locate point A from B. So the bearing of point A from B is what? 060 degrees. And when you are measuring a bearing or direction, when you are using your 3 digits bearing, you will start from the North Pole and you move in a clockwise direction. The North Pole is here, and I will move in a clockwise direction. So from point B, they said the bearing is what? 60 degrees. So I start from the North Pole and I move in a clockwise direction. So 60 will be between 0 and 90. So here I have 60. 60 degrees. So after getting the direction, that's when you can now move. You can't move without getting your direction. So I'm getting my direction, which is the same thing as bearing. So the bearing is 60 degrees, so I'm applying the distance now towards point A. So point A. So after arriving at point A, you also draw your coordinates. Draw your coordinates. Whenever you are making a stop, or whenever you are arriving at somewhere, So whenever you get to on bearing, you always draw your what? Your coordinates to show that that place you stop is a point. So point A and point B, we have arrived at point A, so we put our coordinates. So we are joining the 2 points together, joining them together. So now they're asking us to find what? The bearing of point B from A. So bearing of point A, this point, from B, meaning that we are starting from B going to A. Bearing of A from B is 60. Then the bearing of B from A, what will it be? I told you, whenever you are using 3 digits bearing, you start from the North Pole and move what? Clockwise direction. So now we need the bearing of B from A. So we are starting from A now, and I have to start from the North Pole, move in a clockwise direction. So now, what you just have to know in bearing is that the line that connects the 2 points, it what determines your bearing, what determines your direction. So the line that connects B and A is this line here. So that is where you're going to stop the what? The degree or the direction you're giving. So now we have 60 degrees. We started from the north and we ended it here. That's the line. 60 degrees. So the same thing we do from at A to guess what? Direction to B. So from point A, I start from the North Pole, then I move in the clockwise direction to the line joining A and B. What is the line? Here is the line joining A and B. So I'm starting here and coming like this in the clockwise direction. So I will have to stop at the line joining A and B. So that is my direction from A to B. Bearing of point B from A. Mean that what? From A to B. So I'm starting from A going to point B. So this is my direction. So what will I do? I have to determine the direction here or the angle there. So what is the angle? The angle there is now the bearing of what? Point B from A. So how will we determine that? We come here, this is 60 degrees. We have alternate angle here. I think we have done plane shape. So from plane shape we must have been taught this. So alternate angle to here and here, alternate angle. So here I have 60 degrees. But from here to here is 180 degrees. 180 degrees. Angle on a straight line. So what do I have to do now? I add this and this together, which gives me what? 60 plus 180. Which is equals to what? 240 degrees. So therefore, bearing of B from A is equals to what? 240 degrees. Bearing of what? B from A is 240 degrees. As simple as that. So this is just what? 2 points. Bearing from 2 points. But now when we have a complete 3 points or we have a triangle, we can have what? Also calculate the bearing from there. So this is just one question. So now let's look at another complete question now. Complete question. See, a ship moves from point A km to point B on a bearing point C from A. Bearing for point C from A. This is also a 3 digits bearing, and after this we just look at the compass bearing and end the class there. From here, solution. The ship moves from point A, 60 kilometers to point B on a bearing of what, 045 degrees. I told you, wherever you are starting from or wherever you're stopping, you put your coordinates, or your coordinate points. So here, I have my coordinates here from the starting point. This is the coordinates. This is where I'm starting from, which is point A. Then, say the ship moves 60 kilometers on a bearing of what, 45 degrees. So I calculate 45, 045, that is a 3 degrees bearing. So I have to start from the North Pole, moving what, moving what, clockwise. So I come like this, North Pole, clockwise. Say what? 045 degrees. And now they say the distance is what? 60 kilometers. So after calculating, determining the direction or the bearing, that's when you now apply the distance to the point where you're going. So the distance is what? 60 kilometers. So I arrive at this point now. And that point they say is what? Point B. It's there, meaning that after point B or from point B, it's there from point B now. From point B now, after arriving at point B, it then moves to a point C, 80 kilometers on a bearing of 100 degrees. So I calculate 100 degrees first. Calculate the direction first before you draw your words, before you draw the line for the distance. So the direction here is what? I'm starting from the North Pole, 100 degrees. This is 90, and this is 10. So this is my direction. So I now have to do what? And I have to draw my distance. So now there is another thing you have to note here now. When you are calculating bearing or solving a bearing questions, it has to do with what? The triangle. So you must make sure that the distance are not on the same line if the distance are not equal. It's only when they are equal that they will be on the same line. Because from this question here, the distance from B to C is what? 80 kilometers, which is greater than what? 60 kilometers. So it means that we have to draw the line. It will go below what? The one we have here, below 60 kilometers. I mean it's 60 kilometers the same way, we have it on the same line. If it is 60, 60. If this one is 60, we have it on the same line. The same line. But now it is 80, meaning that what? We have to extend it. 80 kilometers we have to what? Go below. Now it's 80. So we assume this one is 80 kilometers. So where we now stop. So we stop here. So where you stop, you also draw your what? Quadrant. Draw your quadrant or draw your coordinate. I call it coordinate. Draw your quadrant. So this is the quadrant. So now I can join the 2 points to form what? A complete triangle. I can now join the 2 points to form a complete triangle. So this is now point what? Point C. This is what? 100 degree. 100 degree. So what's the question? What's the question? The distance of the ship from the starting point. The starting point is A and the ending point is what? C. So the distance is what? We call it, let's call it small b. And then the bearing of point C from A. So let's solve this one. A. To get this, we have to determine the angle here, which is called the included angle. Angle between the two given sides of a non-right angle triangle is called the included angle. How do you get the angle here? You come here, this is an alternate angle here, 45. 45 degrees, alternate angle. Again, angle on the straight line, this is 100, meaning that here is what? 80. Sum of angle on the straight line is 180. So to complete the angle on the straight line, we remove 100 from what? 180. So we get the remaining here. So meaning that the total angle here now is what? 45 plus what? 80. That will then give us what? 125. 125 degrees. So from here, we can use our what? Our cosine rule to treat this. To find the value of what? B. So you come and say what? Using cosine rule. Using the cosine rule, which says that what? B square is equals to what? A square plus C square minus 2AC cos of what? The included angle cos B. So we are looking for B in small b. So we say therefore our B square then is equals to A square. What is our A? 80. 80 square. Plus what is the C? 60 square minus 2AC. What is AC? Our A is what? 80 and our C is what? 60. 80 times 60. Cos or B. Cos B is what? 125 degrees. 125. So 80 square. So you have B square is equals to 80 square is what? 1600 plus 80 square, 64 is 6400 plus 3600 minus, and this one gives us what? This one will then give us what? For the A times 2, so we have 80 times 60 times what? 2. We have 4802 cos 125 degrees. Cos 125 degrees. Times 80 times 60, 9600. Cos 125. Then from here, this is multiplying. So we add up this. B squared then is equals to 6400 plus this. You get 10,000. 10,000 minus, then cos 125 gives us what? Cos 125 using your calculator. Cos 125 will give us negative 0.5734 approximately. So we multiply this and this. B squared then is equals to 10,000 plus 9600 times 0.5734. So we have 5,504.64. So therefore, our B squared then is equals to what? 15,504.64. Then our B then equals to the square root of what? Square root of 15504.64. Then B is approximately equals to 124.52. 0.52 what? Kilometer to the near to 2 decimal places. To 2 decimal places. So that is what our distance from the starting point. So B, we are asked to find what? The bearing of point C from A. Bearing of point C from A, I told you, whenever you are calculating bearing or measuring bearing, using the 3 digits bearing, you have to start from the North Pole. You move what? The clockwise direction. So bearing of C from A, meaning that you are starting from A going to C. So to start from A, we start from the north, moving clockwise. Then you have to say, what is the line joining A and C? This is the line here. The line joining A and C. So you have to start from the North Pole and stop at the line joining A and C. So I'm starting from the North Pole and then I'm going to stop at the line joining A and C. So this is where I stop. So I need this angle now for me to know the what bearing of what C from A. So I already know the angle of A, of this place was 45 degrees. So I need the angle here. So the angle here, I can say let it be theta. So I say from ABC, from triangle ABC, I need theta. So from here, I know B to be what? 124.52 kilometers. So I know all the 3 sides now. I know one angle. So from here I can apply the what? The sine rule. And say using the sine rule, using the sine rule, sine rule states that what? Sine A over A equals to sine B over B equals to what? Sine C over what? C. Sine A over A equals sine B over B equals sine C over C. So I have to choose 2 which relates to what we want to do. This is theta, we are looking for theta, so I have to use sine A. And then what? This is what we are given. We don't know the angle for this, so we can't take this. So we have to combine what? A and what? B. That's what we need. So we need A and B. So we don't need C because we don't know the angle at C. So we have to adopt these 2. Sine A over A equals sine B over B. So from here, I can get my answer. So sine A, that's what sine theta. What is our A? A is what? 80 equals to sine B. B is what? 125. Sine 125 equals to small b is what? 124.52. So from here, I'm looking for sine theta. I'm looking for theta. So I can cross multiply. See, therefore, sine theta is then equals to, this comes here, so we have 80 sine 125 over 124.52. So, by computing this, we then have sine theta is equals to sine 125, sine 125, sine 125 is equals to, so we have 80 times 0.819 over 124.52. So we compute this and we get sine theta. We say therefore sine theta is equals to 80 times 0.8192, 65.536 over 124.52. 0.52. So our sine theta then is equals to, when you divide this, you then get divided by 124.52. So you have 0.5263. Therefore, our theta is then equals to arc sine 0.5263. What do we have here? Arc sine. Arc sine 0.5263. 526. So theta is approximately equals to 32 degrees. 32 degrees to the nearest degree. To the nearest degree. So that is our bearing of what? The bearing of point C from A. We have not gotten the answer. It's approximately 32 degrees. So we have gotten theta to be 32 degrees. So the bearing of C from A, is the total of what? 45 and theta. So you say therefore bearing so you have 0, and theta is equals to 0, and theta equals to 32, 31.7559. So therefore, bearing of C from A, bearing of C from A is then equals to 45 plus theta, and our theta is what? 31.7559, which is equals to what? 45 plus 31.7559, which is then equals to what? 76.7559, which is approximately equals to what? 77 degrees to the nearest degree. To the nearest degree. So that is it on the bearing. Remember, calculate your bearing from the North Pole when it's 3 digits bearing. Move anti-clockwise, move clockwise direction. Move clockwise direction. Calculate your bearing, apply your distance. That's what we have. Thank you.